Morning, my name is Mike Newman from Johnson Controls. Here to talk to you today about your new chiller, York chiller. This is the YMC squared chiller. This chiller has the magnetic bearing, oilless compressor. So it's very quiet, very efficient. I want to talk to you about the mechanical equipment today specifically so that you'll know what to look for when you walk up to the machine. So I'd like to go through the control panel, show you how to navigate through the control panel, and then walk around the chiller and show you the mechanical equipment, identify each thing for you. There's some unique things about this chiller I want to point out to you today. First of all, this is the OptiView panel. This panel is very easy to navigate through. Got soft keys that when you go to a different screen, it brings up different names on behind each key, and we'll walk through and I'll show you all that. Also inside there's a guide that explains all of the how to navigate through the OptiView panel as well. So you can look through that later on. And I'll go through and I'll identify some pages that will highlight some pages for you to identify some things. So first, on the home screen, when you log into this chiller, you're going to log in under service mode. So someone's already logged in, I'll log out. So we'll log in. We'll push enter, 1380. So we're logged in, so now we can see virtually everything in the OptiView panel. So first is the system switch. When the chiller's running, this is a good overall view of what's going on inside the chiller. Both evaporator condenser, and the compressor and the load. So you can push that screen just to see an overall look of what's happening. To look at a specific component, you can go to the evaporator and you can see the temperature settings and the setting for when the chiller shuts off and when the chiller restarts, and the set point that it's trying to control to. And then all the specifics of what's happening at that moment inside the evaporator. On the condenser screen, basically the same thing. It shows you all the condenser settings, and there is a setting, a refrigerant level control, that it maintains a certain liquid level inside the condenser for efficiency, and that setting is on this screen as well. Let's go down to the compressor screen. The magnetic bearing screen shows what's happening with the magnetic bearing during the run cycle. What position the bearing is in, or the shaft is in. And you can see alarms that are happening in this screen as well. If an alarm was happening, it would alert you, and a soft key would show up and you would go to that alarm. Capacity control basically is all the different levels of limits that you want to place on the machine, and we'll have to go through that more in depth at some other date. There's a lot more to that. And then the VGD is when the chiller is running unloaded. It makes it more efficient when you have the compressor running at a slower speed. The velocity of the refrigerant is slower, so there's an internal ring that changes the velocity. It allows you to run down. This machine can run down as low as 10% load, and this enables that. This allows that to happen. Setpoint screen is where you would go to actually change the chiller set point locally when you're in a local mode. This is going to be on a energy management system, so you'll change the temperature by remote typically, but if you have to run the machine locally, this is where you would go to change that. Okay, I want to show you something. Set points, setup, and sales order is the design of the machine. The job name, it talks about the evaporator flows, the condenser flows, the tonnage of the machine and the specifics of the design of the machine, basically. So if you needed to know something about it, that's how you would find that. And that's in the book as well. And then history. History will be one of the most important ones. If you're going to walk up to this machine because there's a problem, typically, is why you're having to check it. And go to the history, and you can see the last 10 faults in here. After the 11th fault comes up, the last one on the bottom drops off, and then it just keeps scrolling down. You can only save 10. I'd like to show you the inside of the control panel now. So first of all, here's the guide that I was talking about. And then there's some other literature that talks about the motor and the frequency drive as well. And here's the main control board, the brains of the chiller. This is an I/O board that controls inputs, analog and digital inputs, and then the COM card is up here that communicates with the energy management system. This is the link to it. Power supply gives 115 volts comes in and distributes power throughout different components in here through the power supply. And then there are some control relays down here for a digital control. Is this going to be running on ISN or? No,
not on ISN.
Okay, so
hardwired everywhere.
So the hardwire will go through the relays. Basically, energy management will control the relays, which in turn starts and stops the chiller. Any questions about this stuff so far? Oh. Okay. I'd kind of like to go back around the back side of the chiller now and show you the components of the chiller. Talk about the condenser and evaporator barrels, the motor and the compressor, and then the last thing will be the VFD. Okay, now we're going to talk about the compressor and the motor today. This is the control panel for the motor, or the magnetic bearing. So this panel only deals with the magnetic bearing on its own. And so there are, a signal comes from the main controller to activate this, and then this basically does its own thing, maintaining a position of the shaft of the rotor all the time. That's all it does is maintain that. And then after it's maintained, or after it levitates the rotor, the frequency drive then begins to spin the rotor at whatever speed we're looking for to meet load on the chiller. So this thing has a touchdown bearings so that if something happens, if you lost power and the motor was running, it wouldn't ruin itself by touching down where there wasn't a bearing. Those bearings aren't designed to have any runtime on them, but it prevents any damage in case it touches, it hits. Or if there's a mechanical issue or something happens with the impeller and it gets out of line with, out of balance somehow, those prevent any damage, and it senses all that and shuts everything down. So the first thing that happens when you start the chiller is it levitates the bearing, brings it up and maintains its position. And it does that with 4 magnets on one end, 4 magnets on the other, and they're at opposite sides at either end, and so that maintains a position. There are sensors that look at that all the time and measures where it is in its space and just maintains its position all the time. So, and then the other thing is, the other chillers that you're used to are an open drive, whereas this is a semi-hermetic. The refrigerant is around this motor compared to YK. It's open drive. You have an open motor with a shaft seal separating the refrigerant. So this is semi-hermetic. And then the impeller is a direct connect impeller, and where you only have a 3,300 RPM machine, a motor, you can get 8,000 RPM off of YK like that with the gear. Now, now that we've got the shaft levitated, now the chiller starts spinning the motor, and the frequency drive now speeds up and slows down to maintain load of the chilled water coming out of the chiller. Maybe less than 30% or so the VGD will begin activating, and it senses that it needs to activate. On the discharge, there's a pressure sensor, and this pressure sensor compares the discharge of the condenser and the discharge coming out of the compressor, and it compares those, and it sees pulses. That pulse is transferred into a signal that this tries to eliminate. And so that's how the VGD functions. And so now the compressor's up and running, and when the refrigerant's going into the condenser, you want to maintain, because of the design of the condenser, it has refrigerant tubes at the bottom that need to have liquid above the top of them to increase the efficiency of the machine.
Hi guys, my name's Martin Chance, and we're going to go over the leak detection system today. So we're using the ChillGuard RT, which is the same one you guys have over at Morse Avenue, or similar, it might be the exact same one. It's basically an air pump style leak detection system. So we have poly tubing that runs under each chiller, and we have one sniffer under each chiller. It's constantly drawing air in, sampling for refrigerant. If we detect anything over, I think 70 parts per million out here, or no, I'm sorry, 700 parts per million, that's when we're gonna go into a shutdown alarm. On those probes that are under the chillers, they have filters on them. The manual's in here. I don't remember the frequency that they're supposed to be changed, but we have spare filters in the panel here with all the instructions on it. Our panel next to it, we are monitoring 4 contacts off of this, I believe. Warning, trouble, alarm, and it might just be 3. They're all monitoring only except for the alarm contact. The alarm contact, if that closes on this, we recognize it over here. It triggers a whole sequence of events that'll basically shut down your chillers, shut down your pumps. It'll start the purge exhaust fan over there, and it'll alarm you down on the BMS that we have a leak detection alarm up here and everything is off. Inside this panel, we have a bunch of relays. The shutdowns for the chillers are actually hardwired. So we are on the York chiller, there's a contact for shutdown that we're actually hooked up to. So if it sees that contact closure, it goes into a safety shutdown. The smart chiller doesn't have a separate shutdown contact, so we are in line with our command. So basically our command and this shutdown are in series. They both have to be closed for that machine to run. So all that hardwired stuff also ties in to the break glass switches that are mounted at both entrances. So the cooling tower yard and out here, we have a break glass switch for emergency shutdown and for emergency ventilation. If you trigger the emergency ventilation, all you're gonna get is the purge fan. The horn strobes are gonna go off. They're all around here, and there's one outside at each door, and you're gonna get an alarm on your building management system. It's not gonna shut down the machines. It's just going to start the fan and all the lights and sirens. If you do the break glass for the emergency shutdown, it's gonna shut everything down just like this thing would do automatically. These ones are break glass push button style switches. So you break the glass and you push the button in, and it's a maintained switch. So when you push it in, it just stays there until you push it again and it releases. The only other part of this is there is also a key switch out there, only at this entrance for the purge fan. So it's got a HOA basically, and that, if you leave it in auto, it's going to come on if we have a leak detection in here, or if someone does one of the break glass switches, or it'll also come on and off for temperature control. It's not like what you guys have at the Central Plant at Morse Avenue, where we have a continuous fan that's always on, and then we have another purge one. Normally in here, there is no fan running unless we have an alarm or it's cold enough outside, we don't need the fan coil, and we can just turn the exhaust fan on and just draw in outside air for cooling. That HOA, if you turn it to on, it'll just force it on through the BMS, and off will just keep it off through the BMS. There is an HOA at the actual starter of the fan that you can also manipulate. The one out here is really just for the system as a whole. If auto is going to let it work in leak detection or temperature control, anything like that. That's pretty much everything on this, unless you guys have any questions. Nope. All right.
So there's only 2 sensors?
2, just one for each chiller. Both 134A. All right, guys, so we're going to go over the chill water control panel and the condenser water control panel real quick. So we have 2 separate enclosures. This one does everything for the chill water system. So the chillers, primary chill water pumps, secondary chill water pumps. This panel does the towers, so everything with the cooling tower valves, the VFDs for the fans, all that stuff happens over here. A real quick rundown on the sequence. The chillers stage based on load. So basically, well, let me back up. We start a chiller based on valve position of the air handler. So if any one chill water valve gets over 30%, that's when we turn the plant on. It picks a chiller with the lowest runtime, and it starts that one first. If that chiller gets above 95% load for X amount of minutes, we bring on a second chiller. That's really the basic staging of the plant. All your pumps are headered, so you have 3 condenser water pumps, 3 primary chill water pumps. They also rotate based on runtime, so there is no direct relationship with pump 1 goes with chiller 1 or anything like that. We are starting a chiller, we're picking the primary chill water pump with the lowest runtime, condenser water pump with the lowest runtime, and then away we go. We have isolation.
For 1 second.
Yeah.
Ed, I hear you guys too loud over there. Can they hear me? Ed, I hear you guys too much in the background. Just back up a step and start over.
Okay.
If you can figure out what that is. On 1, 2, 3, go.
Okay, so we'll pick a primary pump and a condenser water pump with the lowest runtime anytime we start a chiller. We have isolation valves on each chiller, one on the condenser water side, one on the supply side. And then out at the tower, we have isolation valves on supply and return of each cell. So once we start a chiller, we start a condenser water pump, a primary pump. We have a tower running, everything's happy, honky-dory. The towers actually stage based on temperature, so we can have 2 tower cells open with only 1 chiller running if we need to. So the towers kind of stage independently of the chillers. If we do get into a situation with both chillers running, then we just force both towers on, and there's no more staging. They just ramp the fans to maintain set point. The fans will ramp together always. If we have 2 towers running, those fans will be ramping together, always running at the same speed. And out there, we're controlling for condenser water supply temp. And that's obviously adjustable. The condenser water pumps have VFDs on them. The primary chill water pumps do not. On the primary pumps, there's also no handoff autos on the starters. So if you want to start those pumps manually, the easiest way to do it is coming over here to this panel. All of our commands, just like at Morse Avenue, we brought to relays before they go out into the field. So you should be able to come to these control panels, and if you need to manually open any isolation valves or start any pumps, you can walk over here, and this is for chill water pump 1. You can flip the relay on, and the pump starts. You don't have to go over there and try and jumper out the starter because there's no HOA. You can just do that, and that's for all the commands that come out of both of these panels.
So the secondaries don't have VFDs on them?
Secondaries do have VFDs, just the primaries.
Okay.
So the only pumps in here that don't have VFDs are the 3 primary chill water pumps, and they don't have starters either.
Constant flow.
Yeah, those are just constant flow because we are on a primary secondary system. So the primary pumps are constant flow, secondary.
And the secondaries are staged.
Second-
One pump comes on first and then
Yep. Yeah. So the secondary pumps are chill water pumps 4 and 5. 1, 2, and 3 are your primaries. 4 and 5 are your secondaries. Those control for differential pressure. That sensor is down at air handler 4, mounted on the air handler, and those pumps will try to maintain whatever that set point is. I don't know off the top of my head because we've been messing around with it with the balancer, but they will try to maintain. So if we have one pump that gets to 100% and it can't get to whatever our DP set point is, it will stage on the second pump after 5 minutes and run 2 pumps in parallel to try to maintain. Once we achieve set point and the pumps get below 60%, I believe, we drop back off.
The DP pressure set point auto adjusts on demand of what?
No, it's going to be a fixed. Yeah, it's going to be a fixed set point. I believe it's going to be right around 8 or 9 psi is what we were seeing last week. So I got to confirm that with the balancer, but that should be where we land. And that's the same control strategy for your boiler system too. So basically 2 parallel pumps that control for DP. That DP sensor is hardwired from air handler 4 all the way up to the controller. We're not using the network to share the information. So we should have good, reliable control as long as that sensor is working. Trying to think if there's anything else. I think that's pretty much it, unless you guys have any questions. There's a lot of stuff I'm kind of just brushing over it real quick. So hit me with questions if you got them.
So how is it staged again with chiller? Is it lead lag? Is lead lag then?
It's runtime. So when the plant is enabled, it'll just pick the one with the lower runtime. And we're calculating that runtime on the BMS. We're not getting a real runtime value from these chillers. So obviously the existing chiller has more runtime than the York does, but we're just totalizing the stat or our command to these chillers starting, now since we brought this online. So they both started at 0 on our system. We know in reality that's not the case. So if you want to if you want one chiller to run and not the other, there's a couple ways you can do it. If you want to keep the staging control there, you can just manually override that runtime value on the chiller and you can put it to some really high number, and that will always make it the lag chiller. There's also a maintenance switch for each one in the BMS where you can basically just take it out of service and say, I don't want chiller 2 to run at all because we're either doing maintenance on it or we don't need it, whatever. You can just disable that point and it'll just ignore chiller 2 and just keep going to chiller 1. So